So, next is the type 3 modification. In this case, an old bus J is connected to the reference bus. This is an old bus. I told you I and J old bus. So, connected to your what you call to the reference bus R through an impedance ZB, right. So, if we go back to this your I mean if we go back to that your figure 7, right. I mean this this is your figure 7. It was shown that a new bus is connected to an old bus, but if you bring this node connect this to this point, right. So, in this case only ZB impedance will be there, and in that case IK will be 0, right. So, that means that old bus connected to the reference bus. So, in that that is why I am showing to that figure your what you call 7, right. If bus K is connected to reference bus R, then Vk will become 0, right. Sorry, that in this case that this bus if you bring it, then Vk will be 0, right. So, not the current. So, in this case your that same equation 20a, that 20a you rewrite everything, only put Ik is equal to 0, right. Because in this case that your as soon as you bring this node to here, right. So, node that is old bus connected to reference bus, that means there is no question of increasing the dimension of the Z bus matrix. So, in this case that your it is actually 0, right. Ik is 0 sorry Vk is 0 and rest of the equation same. From this equation what you have to do is you have to find first that expression of Ik. So, in this case this last row, just hold on, this last row can be written as that this one, this last one can be written as that Vk is 0, Zj1 I1 plus Zj2 I2 up to Zjn In plus your Zjj plus Zb into Ik, right. So, everything will remain same, only Vk will be equal to 0. From here you will get Ik is equal to minus 1 upon Zjj plus Zb into all these terms, right. So, expression of voltage for ith bus can be written as, so suppose ith bus we write Vi is equal to Zi1 I1 plus Zi2 I2 up to your Zij Ik, right. In this expression here you substitute Ik is equal to this expression, you substitute, right. If you substitute, that is this is from equation 24 and 23. So, if you substitute, then you will get your Vi is equal to Zi1 minus Zij Zj1 upon Zjj plus Zb into I1 plus Zi2 minus Zij into Zj2 divided by Zjj plus Zb into I2 up to nth term Zin minus Zij into Zjn upon Zjj plus Zb into In. This is equation 25, right. Now, by inspection using this whole thing, that this Zi1, Zi2 basically elements of the old J bus, and these are the changes, So, if you put them in a from your intuition, if you try to put them in matrix form, then Z bus new will become Z bus old minus you have the term here Zjj plus Zb, Zjj plus Zb everywhere minus 1 upon Zjj plus Zb. Then you have the, in general you have the product Z1j, Z2j up to Zij, then Znj, then Zj1, Zj2, Zi up to Zjn, right. Because these two product is there Zij, Zj1, Zij, Zj2, Zij, Zjn. So, this is your column and this is your Z1j, Z2j, Zij, Znj, and this is Zj1, Zj2 up to Zn, and this Zi1, Zi2, these are the old element of the old Z bus matrix, and this term have been written in this form such that computationally you can compute this way, right. And Z1j is equal to Zj1, it is same symmetric matrix. This is equation 26. This is actually type 3 modification, right. So, little bit just just little bit of practice, right. And in the case of type 4 modification, here I will only give you the final expression and I will request you to derive this part, right. So, type 4 modification, in this case old bus are connected, your two old buses are connected and impedance between this bus is ZB. I bus and J bus, these are two old bus and this impedance is ZB, right. So, here direction of the current is taken here IK. So, here it will be II plus IK and here it will be IJ minus IK, and this is the passive linear n bus power system network. So, two old buses are connected to bus impedance ZB. So, that means, in this case also that order of the Z matrix will remain same, only it will be modified. So, if you write the equation of Vi using, look at this diagram, if you write the equation of Vi, you can write Vi of Zi1 I1 plus Zi2 I2 plus up to Zii into II plus Ik, because current injection here II plus Ik, right, plus Zij, that is I to j, here current injection Ij minus Ik, that is plus Zij Ij minus Ik up to Zin In, and also that Vj is equal to Zb Ik plus your Vi. So, in this case you just what you do, you just apply your this thing KVL in this, you draw this diagram like this, right. I have to show that, just hold on, right. This is your Vi, Vj and disconnected. So, this is your bus I and this is your bus J, right, and this is your reference bus voltage Vi and this is your bus J, this is your reference voltage Vj, right, and this is actually connected your what you call by impedance, this is connected by impedance Zb, right, and your this direction of the current is taken as Ik, right. So, this is the simplification, that how you can make it. So, if you connect here, I mean if you draw this and put the Zb, then apply KVL, then your this thing Vj will become Zb Ik plus Vi, right. So, that is why where it has gone, just hold on 2 pages. So, this equation, that equation 28, right, that is your Vj will be is equal to your what you call that your Zb Ik. Actually, it is a simple thing. This Zb, this is your, if you take this line like this, if you like this, this is your I, this voltage actually it is Vi, right, this is your reference, and this is your J, this voltage is Vj, and then you have Ij, you have the impedance Zb, and this is your current direction is this way Ik, right, Ik. So, it will be actually Zb Ik plus Vi minus Vj is equal to 0. That means, your Vj is equal to Zb Ik plus Vi, right. So, though this Vj is equal to your Zj1 I1 plus Zj2 I2 plus Zji Ii plus Ik, right. So, Zji, that is your Ii plus Ik, right, plus Zjj Ij minus Ik plus your Zjn In, because we have written Vi is equal to all these things and Vj is equal to your this expression Zj1 I1 plus Zj2 I2 plus Zji Ii plus Ik plus Zjj Ij minus Ik plus Zjn In, right. So, that means this expression is equal to this one plus this expression. So, if you, that means this is Vi is there, Vj is there and this expression is there. So, from equation 28, 27 and 29, right. So, this is actually your, then that means this one actually your, this is your what you call that V j is equal to this is Z b I k plus V I, the whole expression. Then you 0 is equal to bring everything together, left hand side you 0 is equal to bring everything in one side, then you simplify, this equation will be coming like that. From here you get I k expression of I k, this is a big expression, but you will get expression of I k in terms of I 1, I 2, I I, I j everything. Then in the expression of V I you substitute I k, and after that you will get that expression, that your what you call that expression of your Z new Z bus. So, Z I j is equal to Z j I, and coefficient of I k is Z b plus Z I I plus Z j j minus 2 your what you call Z I j, because in this expression Z I j is equal to Z j I. So, it will be minus 2 Z I j in this expression, it is, that is equation 30. So, and coefficient of I k is this one, that means we can write same thing V 1 V 2 V n, that as if V k is equal to 0, and this will be, this 0 will be equal to whatever will come, this I k you have to find it out. So, this way it is written that 0 is equal to this whole thing, right, whole thing. So, that is actually written here. After that you will, from this equation only or from here you find out I k is equal to in terms of I 1 I 2 divided by this one, right, whatever way it comes, and then if you do so you will get some expression, and from there this part you will derive, right, because this Z bus old will be there, but this modification will be there. It will become Z b plus Z I I plus Z j j minus 2 Z I, that is the coefficient of I k. I told you that you I k you find out and put in the expression of V I, then you generalize, right. It will become Z 1 I minus Z 1 j, Z 2 I minus Z 2 j up to Z n I minus Z n j, right, and into it will be Z I 1, it is 1 I Z I 1, here it is Z 1 j minus Z j 1, same Z I 2 minus Z j 2 up to Z I n minus Z j n. So, this is actually type 4 modification. So, there are 4 types of modification that for your question is, first is your we have to say some old buses, new buses and the reference bus, and from there we have to start the construct your forming that Z bus matrix. So, this is actually we have assumed some old bus, new bus and reference bus, but if some problem is given, suppose some problem is given, you have to start from the scratch, then how one can start? Reference bus is given, and any bus you start from the scratch means that bus will be a new bus. Once a bus is already considered means that bus bar will be an old bus, right. So, this expression of this type 4 type 3 looks like little bit of huge mathematics, but you have to do it systematic way. In any way, we will take for this one simple example, a simple example. For example, this figure 10 that is shows a 3 bus power network. Our reference bus is there, bus 1 to 2 it is given 0.2, j another thing not putting and again, but ultimately j is there, but understandable. It is also bus 3 is also here, this is bus 3, it is 0.2, 0.2, 0.5, 0.5, right. Sorry. So, now we have to start from step 1, because here no Z bus old is there, we have to start from the scratch. Look how simple it is. Now, we have to do add branch Z 1 R, that is 0.5 per unit say. That means, from new bus 1 to reference bus 1, because nothing is there. So, any bus we are considering it is a new bus first, right. So, 1 to reference bus only single element. So, it is a type 1 modification. That means, your initially and this once this bus 1 is considered as considered already, right. So, next step this bus 1 will become an old bus, because already we have considered that one. So, only one element. So, what we will do Z bus, first you start 0.5, right, because 1 to bus 1 to R, the reference bus, it is 0.5, right. Next, step 2, type 2 modification, that is add branch Z to 1, that is from new bus to old bus 1, because already this bus 1 we have considered previously. So, this bus will become old bus. Now, this bus is a new bus. So, add your from an old bus to a new bus. So, if you add this old bus to a new bus, so it will become Z bus will become 0.5, 0.5, 0.5, 0.7, that how it is coming. So, if we just hold on, let me bring that this thing that expression, just hold on, right, just let me find out. Just 1 minute, everything is mixed up, just hold on. Just hold on. If I tell from my mouth, you may not understand, right. So, just hold on. If I find it here, it is fine, just hold on. Just hold on, where it has gone. Oh, just hold on, just hold on. I will show you that formula, from that you can do it. Just hold on, right, it is where it has gone. Type 2, this is actually type 2 modification, 40 this number, it has gone. This is 49, 47. Anyway, I am not where it has gone. I am here. I have got it here, right. For example, this one, right. This is actually type your this thing 2 modification. So, when your this old one to new one you are adding. So, this will be actually, this is a 2 into 2 matrix. So, Z when j is equal to 1, this is j is equal to 1 and your k is equal to 2, right. So, in this case, when j is equal to 1, it will be j 1 1, z 1 1 rather, right, and this is actually here also it will be z 1 1. So, z 1 1, the previous one, it is actually 0.5, right. So, that one your z bus, first one we got, this is 0.5, this is actually z 1 1. So, it will be also z 1 1, it will be also z 1 1. So, because it is always 3 bus problem. So, j is equal to 1 and old bus, it is also z is equal to 1 old bus, and then this is z j j plus z b. So, z 1 1, because j is equal to 1, and k is equal to 2, and this is the branch impedance we are adding 2 to 1, 0.2, that means it will be 0.5 plus 0.2. So, 0.7, this is type 2 modification. So, this is actually Z bus when we are adding new bus to old bus, right. Next is your this step 3. In this case, add branch Z 1 3 your from new bus 3 to old bus 1. This is also type 2 modification. That means, you add bus 3 to a new bus 1, your this new bus 3 to old bus 1. In this case, what will happen, that new bus k is equal to 3 and j is equal to 1. This way you will do it, and z b is equal to z 3 1 is 0.2, because 3 to 1 is 0.2, and z j j, that is 1 1, because j is equal to 1 is 0.5. So, z b plus z j j, that is z b plus z 1 1, 0.2 plus 0.5, that is 0.7. Using the same expression, using the same expression, that when j is equal to 1, that means it is Z12, when j is equal to 1, Z21. So, 0.5, 0.5, 0.5, 0.7, it was there, that this matrix is there. In addition to that, this is also coming 0.5, this is also coming 0.5, and ZB plus ZJ, that is 0.2 plus 0.5, this is 0.7. This is also type 2 modification. I mean next step, because you have to consider in this network, you have to consider all the your nodes, right, and the reference bus reactance impedance also. So, that means here when j is equal to 1, because dimension is increasing. So, k is 3, j is 1. So, this already you have got, when j is 1, Z12 and your z is 1, Z21. So, this equation Z12 and Z21 0.5, 0.5. So, here also it is 0.5, 0.5, 0.5, 0.5, earlier it was same thing 0.5, 0.5, and this one your ZJ11, Z11 plus ZB, that is your this is your what you call coming at 0.7. So, here it is 0.7. So, here it is also 0.7, here it is also 0.7, right, and similarly if you put j is equal to 1, you will get all these things Z11, Z21, Z11, Z12, 0.5, 0.5, 0.5, 0.5. This is type 2 modification. Still something is left. Next one is that is step 4. This is step 3. Now, step 4. Step 4 is that add branch Z2R from old bus to reference bus R. This is old bus 2 and this is your reference bus R. So, Z2R actually 0.5. So, in that case this is type 3 modification, right. So, in this case old bus j is equal to 2, because already a bus is considered. So, that bus will never be a new bus, it is an old bus bar. So, j is equal to 2 and n is equal to 3 and ZB is equal to Z2R, that is 0.5. So, Z bus new is equal to Z bus old. Z bus old means this one is the step 3 calculation, this is your Z bus old, right, minus 1 upon Z22 plus ZB as per your equation 26. That is a huge equation, but it is only 3 bus problem. It will become 1 upon Z22, that is ZJJ plus ZB, j is equal to 2. So, Z22 plus ZB, this is Z12, Z22, Z32 and this is Z21, Z22, Z23 only from this equation. So, all these Z12, Z22, Z32, all these things are known from this your step 3 calculation, from this your step 3 calculation, right. All these things are known. So, in this case if you compute Z bus new, then it will become your, just hold on. So, it will become your this one. If you do so, this Z bus all computation you have to make, it will become Z bus your this thing, but still it is not completed. One more branch is there, that is step 5. In this case add branch your 2 to 3, because that is not added, step 5. So, add branch 2 to 3, that is Z23, that means from 2 to 3 you add, right, 2 to 3 you add. So, in that case your old bus 2 to old bus 3, because this bus 2 and 3 already we have considered. So, these are actually bus 2 and bus 3 are the old bus, right, 2 are old buses. So, in that case it is a type 4 modification. So, n is equal to 3, I is equal to 2, j is equal to 3 and ZB is equal to Z23.20. So, equation 32 if we write like this Z bus old minus 1 upon ZB plus Z22 plus Z33 minus 2 into Z23 and Z12 minus Z13, Z22 minus Z23, Z32 minus Z33 into Z21 minus Z31, Z22 minus Z32 and Z23 minus Z33, right. So, from equation 32 you can write this equation, and from Z bus old means previously whatever we have obtained, that will be always Z bus old. It is something like a iterative process, right. So, once you substitute all these values and all this Z element will come from this previously computed one from here only, and if you substitute all, then Z bus will become this one minus whatever parameters are coming you put, right. Then you see your what you call you simplify. If you simplify, then Z bus finally I am putting a J here, throughout I did not put again and again. So, this is your 3 into 3 Z bus matrix, this is actually answer. So, computationally it is your what you call that computer thing is required, right, and coding is required, but even this problem also, this problem for 3 bus problem, it will take it also takes time, right. So, because lot of computations are involved. So, but this problem can be simplified, right, because here 1 2 reference bus, this is a reference bus, 2R is given, right, this way. So, if we give it suppose 2 bus 1 and 2 and only 1 reference bus, suppose this thing is not there, suppose there is 1 3 and 2 3 is not there for you, only 1 2 is there, 1 2 reference bus and 2 2 reference bus. As an exercise you can compute what will be the Z bus matrix, because as far as this is just to show you that how to do it, right, and lot of pages are there, sometimes getting mixed up. So, this is your what you call that Z bus formulation algorithm, right. So, and your so then another small example we will take, that is your figure 1, that is shows a sample power system network for a solid 3 phase fault at bus 3. So, you have to determine a fault current, then V1F and V2F, and see fault currents in lines 1 2 1 3 and 2 3, and D IG1F and IG2F. So, this is the diagram, right, and transformer reactance is given 0.1, generator 0.4, but if you look at the 1 2 3, that 0.2, 0.2, 0.2, this is actually 0.2, 0.2, 0.2, right. The same data taken, right, and we have to find out fault currents and the other thing, that line fault currents and IG1F, I2F and your V1F and V2F. So, using equation 8, this one you can write IF is equal to VR0 upon ZRR plus ZF. Fault has occurred at bus 3, then R is equal to 3, that is faulted bus. So, in this case this is 1 2 3, right. So, Thevenin's passive network for this system is shown in figure 10, that means this figure, this figure 10, because here the generator is 0.4 and this is 0.1. So, 0.5, here at a 0.1 and 0.4, it is 0.5, right, and when fault has occurred, the generators, that all that in ground is the reference, because your fault has occurred. So, basically this is if you add this to 0.5, if you add this to 0.5, and ultimately this is actually equivalent, this network equivalent is this one, and this Z bus its Z elements will be used, Z matrix will be used. So, this one, this Z value will be used from this one only, right, whatever we have got this Z, because similar identical one, this Z will be used. So, question is that for this kind of problem, if it is given, if you solve, generally we supply the Z bus matrix, otherwise no one can one cannot solve this one cannot, it will take more time to get this your what you call Z bus matrix. Generally Z is supplied, Z will be given. So, now that IF is equal to VR0 upon ZRR plus ZF. So, this Z33 actually a faulted bus is this one bus 3. So, it is your Z33 and ZF fault impedance, it is a solid fault. So, ZF is 0. So, IF is 1 upon J 0.35, that is your Z33, that is minus J 2.85 per unit. This Z matrix we are using from that previous example. So, using equation 11, that is VIF is equal, this already we have derived, is equal to V I 0 minus Z I R upon Z R plus Z F into V R 0. So, when I is equal to 1, you can calculate V 1 F is equal to this much 0.2857. Similarly, for I is equal to 2, you calculate, you will get 0.2857 per unit, and fault has occurred at bus 3. So, V 3 F is equal to 0. Now, using equation 13, so I F I j is y I j V I F minus V j F. This is a general thing, right. Now, I is equal to 1, j is equal to, all you substitute. So, in this case, you all substitute all these values known to you, right. So, you can get I F 1 2 will get 0, all are calculations given. I F 1 3 you calculate minus j 1.4825 per unit. Similarly, I F 2 3 you calculate, you will get minus j 1.4285, all you will get, right. And last one is that you are using equation 14, this is the last one, right. So, I F G I is equal to V G I dash minus V I F divided by j x G I dash plus j x T I. So, note that transformer reactance is also included in the above equation, right. So, V G 1 dash is 1 per unit pre-fault no load voltage, V 1 F is calculated, x G 1 is given, x G 1 dash 0.4 is given, x T 1 is given. So, I F G 1 you can easily calculate, substitute here all these values, you will get minus j 4286. Similarly, I F G 2 also minus j 1.4286. So, in this case actually, so 3 phase fault, whatever I mean, we have taken some critical thing, and particularly the Z bus building algorithm. So, step by step your what you call, you have to formulate, and couple of examples also that has been shown to you, that how to compute the fault voltages and for your line fault current. So, and we have shown that how to go for Z bus building algorithm. So, in that case what you call that just step by step you have to move, but lot of computation is involved. But whenever problems are given, numericals and other things, generally Z bus will be provided. Otherwise, in the classroom it is not possible to compute Z bus without your computer. But one thing I can tell you, that Z bus coding actually is not difficult, it is quite easy. But my suggestion to all of you, when you will practice this, particularly the Z bus building algorithm, just have patience and make calculations. So, just for a simple 3 bus problem with a reference bus, you have seen that how difficult it is. Even here also I have so many papers, it is getting mixed up, right. So, thank you very much for listening this. Thank you.